and up to how much level we can perform. But ultimately, what is right and what is wrong, that is the call of the researcher, and that is where our roles and responsibility will come into the picture, that how we can tackle those particular aspect into the practices, right? So that is where the technicalities needs to be understandable. And it has been said that data analysis and interpretation should always be happen in a positive and the right directions, so that it will have some relevance, it will have some importance, and it will give some fruitful results in the future. And that is where it is very very important that we should understand the importance of the data at each and every moment. Then only it would be able to provide the results in a right manner, right? So when we talks about data analysis, tools and techniques, so there are a lot many tools and techniques which are available for data analysis. But before talking about data analysis, we need to talk about which kind of data will be applicable to which kind of series, right? So first of all, we need to talk about that we have a different sort of data, and according to those sort of data, we need to apply the different analytical tools. But before talking on this particular front, we need to first understand that when we have the technicalities and we have the technical knowledge about the different types of data and the data analysis tools and techniques, right? Then one thing that we need to ensure, and one thing is very very clear, that how we should collect those kind of data. So the data collection is very very important on this front. And when we are talking about the data collection, it is very very important to understand how you can convert those collection of data into right kind of manner in terms of data collection, wherein let's say if I need to talk about the data collection, first of all, so we need to understand the types of data that we have it. So how many types of data that we have it. So here is the answer for this question, that we have basically four types of data. The first data, as you can see on the screen, is nominal scale data. So what is nominal scale data, as we have already discussed? So when we need to,
Excuse me, sir.
yes,
Screen is not visible, sir. I don't know for the others.
okay,
Your
okay, okay.
presentation screen.
Right. Thank you. Yeah,
You're welcome, sir.
yeah, it is visible now.
Yes,
Right.
sir. Thank you, sir.
So we need to first understand the types of data that we have it. So when we talks about nominal scale data. So what is nominal scale data? So nominal scale data, basically yesterday we had talked about, so nominal, ordinal and interval scale of data are those scale of data where we don't allow respondent to answer in an open-ended way, right? So these are the types of data where we are not allowing the respondent to answer in a manner they want, but it is completely the close-ended data that we talks about. So that is where it is called nominal and ordinal data, and interval as well. So here, our answer frame is limited. We want the answer in the limited frame of, the range of data, but we want that everybody should answer in a proper way. And that is where whatever data that we will collect, that should be in a position of analytical point of view, right? Because normally the data that we are trying to cover from nominal and ordinal scale data are usually qualitative data that we are trying to cover up in terms of quantitative, right? So we assume that this kind of data should be properly managed, and that is where those qualitative data can be easily converted into quantitative, right? So that is where we will try to cover up them into different categories, right? So let's say if I'm talking about the gender, so the people gender, right? So if I need to talk about that which gender that you have it, right? So people might have the answer like, gender is male and female. So again, the male and female is a common terminology, but if I need to make a data cleaning and data coding, right? After making data cleaning, I need to have a data coding. So I need all the answer on a common platform wherein I can have the cleaning of data, and at the same time I can make the proper codings of the data, so that whatever data that we will cover up, that should be analyzable, right? So that is where my work as an analyst is going to be mostly sorted out in analytical mode. So that's where I have to arrange those kind of data. Again, If certain data that I don't want to make it in an open-ended question, like, if I need to ask someone that what is your age, so age can be quantifiable, right? In terms of like, 30 years, 35 years, 40 years. So that is a quantifiable, right? That should be number, but that should be very open-ended, right? And again, the way people respond to this particular question would be different. So after collecting data, so somebody will answer like, my age is 35 years, right? Somebody would answer like, my age is 40. Why? That is not complete year, they just write y, right? Somebody will write years in y in capital, somebody is write in small. So here the different types of answers would be gettable, but instead of doing that, if we want the appropriate sort of data where 5 years or 7 years age difference will not matter, and that could be countable as a part of common age group. So that's where we can convert those things into age group, right? So that is where we have to quantify them into different age group, right? So that is where ordinal scale will come into picture, right? So let's say up to 25 years, 25 to 50 years, 50 years to 60 years, and above 60 years, right? So that is where the range of group that we have to cover. But although the sequence is always expected to be in a range because it is a quantifiable number data. So whosoever will try to answer your questions, they will always assume that it should be in sequence, right? So that the respondent should not miss out the other categories of the data that they have to select. So that is why it is expected that those kind of data should be in numbers. So that is where the ordinal scale data will come into picture. Okay, and then interval data. So the same thing, just like an ordinal data, but the only one difference in between ordinal scale data and the interval scale data, that in ordinal scale data, again the data sequence or the categories of the data should be in sequence, right? But here in interval scale data, the category of data should be in sequence, but although the bracket of difference, like the difference amount, like let's say less than up to less than 20 years, right? Then 20 to 30, 21 to 30, 31 to 40, 41 to 50, right? So here in this particular option, you observed that the difference between the age group, different between the options that we have provided to the respondent are on a common bracket, right? So that is where 10 years of age bracket. So that is where it is considered to be interval scale data, right? And finally, the fourth category of data is the ratio data that contains the numerical form data, that contains the ratio numbers, right? So that is always quantifiable in terms of numbers, right? Just like a stock prices, as you can see on the screen, like an example. So stock prices is one of the data. Even the age factor, if I'm not providing the categories to the respondent and I'm forcing them to answer in the numbers, so again, the age data can be considered to be the ratio data, right? Which is in pure number. So that is what we have to take this into consideration, right? So this is one aspect that we have to see. Okay. So when we have the data in hands, so there is one particular things through which we start our journey. Like it is a normality testing. So we must have to consider the test of normalities that will come into the picture. So normality means whether the data is having normal distribution or not. That means they are distributed in the range of bell-shaped curve. According to that, we have to give the treatments to the answer, right? So let me drag you to some of the data kind of things. Uh, so I'll show you one particular thing, like, this is an annexures. You can see these annexures, right? And I want the answers from you, right? So this is a first category, right? So we had discussed about the type of data that we have it. So which kind of data it is? When I have asked the age group, which kind of data it is? Is it nominal? Is it ordinal? Is it a scale? Or is it a ratio data? Which
The
kind of
first
data
one
it
is
is?
the first one is interval, it's the age one.
Age is interval. Perfect.
Yeah.
Right? Because
Yeah.
at the first instance, it is ordinal, right? Because it is in the order. But that order again is in the unique sequence, right? Unique difference. Everywhere the difference point is unique, right? 10 years of age bracket has been given. So that is where it is interval. If it is not in a common breakage, right? Let's say if I'll change like up to 20 years, then second option would be 20 to 35, and 36 to 45, 45 to 60, and above 60 years. So this is called ordinal scale data, where the scale is not common, right? So it is not in a interval data, right? So if ordinal data is in the scale or the sequence, that turns into interval data, right? So then gender, the two options has been given, male and female, right? So gender is what?
Nominal.
Nominal. Perfect. First of all, being a nominal and ordinal or interval, there is one point of difference. Like, nominal data, you don't require any sequence. While in ordinal and interval data, you need a sequence. So first, the difference point is whether the sequence is required for the, multiple choice questions or not. So if the sequence is required, then it would be either ordinal or interval data. But if the sequence does not required, it is a nominal data, right? So that is the first aspect that we have to see. Then, if the sequence, in this particular aspect, like if I have to ask someone that what is your gender, so should I put male to be first or female to be first?
Any can be there, sir. Either male or
Yes.
female.
So your answer says any can be there. So that means sequence does matter or not? Does
No,
sequence matter?
sir.
Is no, right? So
No.
when sequence does
No.
not matters, the order does not matters. So this kind of data is called nominal data. Yeah. So
Okay.
gender is considered to be the nominal scale data. I hope I'm making
Nominals.
sense,
Okay. Yes, sir. It's
right?
clear. Thank
Right.
you. Yes, sir. Thank you, sir.
Just like you see the highest education, right? So high education could be secondary, graduation, post graduation, professional careers, and other. Now somebody says, yes, sir, graduation, education should always be in sequence. I agree with you in the sequence, but does this sequence is applicable to all in the same manner? As if like, if I'm 12th graduate, right? So I should always look forward my option like 12th graduate. It doesn't matter, it always start from like PhD to 12th or 12th to PhD. I will always see my option, right? So in this case also, the sequence does not matter because the education qualification would be different for different categories. And again, for educational qualification, the hierarchy is not in a numerical sense. That means the educational qualification have both the, gratification, like, vertical and, horizontal. Wherein like, if I'll start with 10th, 12th, graduation, post graduation, and PhD. While on the contrary, if some people are not doing, masters and they have a professional degrees, like a CA, and if they are CA, they don't do the doctorate also, right? So in that case, which option is the highest one? Should I consider doctorate to be the highest one? Should I consider postgraduate to be the highest one? Or should I consider the professional degrees to be highest one, right? So there is no specific answers to define the sequence of these options. Yes or no?
Yes, sir.
Right. So again, this is a nominal scale data, right? Again, occupation, again, sequence does not matter. Nobody says that farmer will come first and businessman come should last, right? So there is no sequence. So this is nominal, right? But if you come to annual income, so it's a numeric data, right? So when numeric data can be converted into options, either they would be ordinal or it would be internal. If the bracket of the sequence has been considered to be in an equal mode, it is interval. But if it is not in equal mode, it is ordinal, right? So that should be order. So here you can see this below rupees 5 lakhs, 5 lakhs to 10 lakh, 10 lakh ones to 15 lakh, 15 lakh ones to 20 lakh, and above 20 lakhs, right? So this is how the things are going into sequential mode, right? So that is where it is called ordinal data, right? So this is how you got the clarity what I was saying. Now, if I need to show you this particular aspect into SPSS file, so same demonstration I would like to show you on the SPSS file. right? I hope the screen is visible to all of you.
Yes, sir.
Okay. So now you can see this, the same things we discuss is on the screen. Clear?
Oh, yes, sir.
Right. Fine. So age is can consider to be ordinal, right? Because you can see these values over here. It is in sequence. So we have started with the lowest age and we have extended up to the highest age, right? So that is where the age group is in sequence. Clear? So this is a sequential matters. Then you can see the gender. Gender, you have two options. One is male and two is female, right? Again, there is no options or there is no sequence does matters to you. So that is where male and female will come into picture. The education is, you know, higher secondary, graduation, post graduation, professional, and others. Although I have to give some numbers, but again, in terms of data, by mistake it is ordinal, but it is nominal, right? So it has to be nominal. Occupation, again I have to give the codings irrespective of the sequence, but this is 1 2 3 4 5 because ultimately when we are collecting the survey, if I ask someone what is your occupation, so this particular answer is qualitative, but when we need to convert them into quantitative because we want to do the analysis, right? So we always have to give the some sequence or codings to that particular options. Clear? So that is where we have to work out. Fine. Okay. Now, so this is one of the other aspect, right? So now let's see analysis point of view. So if you need to generate the normality data, what you need to do is you need to go to descriptive statistics. So this is very important. When you have to do any analysis in SPSS, so this particular option called analyze is very, very important for all of us because 80 to 90% of the analysis work in SPSS is happening in this particular menu, which is called analyze, right? So here we have to analyze the sequence. So that is where we have to write like a descriptive statistics. And in descriptive statistics, we would like to have the frequencies. So if I need, how much age people are there in different categories, so I have to press statistics. If I need some add-on features into this, like if I need mean, standard deviation, right? So this is where we have to click on it. If you want charts, by charts and everything, so it will be generated by the software also, right? Format, nothing like ascending descending, but we have already arranged in ascending descending because it is ordinal data, right? So there is no need when you pick up the ordinal data in a sequence. So you can see this, you have this pickup option, click OK, and the result is generated. You can see this comparisons. Yeah, you can see this. So this is stable, and this is a charts, pie charts, which has been converted into analytical point of view. Clear? So this is frequency distribution, right? And along with that, we have ensure some, descriptive statistics in terms of mean, median, and mode kind of things, right? So this is two aspect that we have to take out. Okay. Then, right, when you have to apply the normality test, usually the function which is applicable to apply the normality is explore. Clear? What option we need to apply? Explore, right? So this is where we have to apply the explore button, right? So analyze, descriptive statistics, and explore, that you need to apply. But always do remember that normality test can be applied only on scale data. Now, what is a scale data? So scale data in SPSS is interval data or ratio data, right? Just like, if we are asking Likert scale data and to rate particular things into 1 to 5 ratings, so it is a scale data, right? Which is in pure number. So whenever you apply normality test, it can be applied in scale data usually. In some cases for ordinal also. Otherwise, usually it is applicable to scale data, right? So this is how you have to select the particular data, and that would be converted into normality test. Clear? So if you select all this and if you drag this on this side, So, and if you click on statistics, right, plots, and when you apply normality test with probability values, so you always have to apply normality plot with test. So here you have to click on this normality plots with test and keep continue. Then you have to click on options, click continue, and again if you have to click on this bootstrap, again it is continued. So if you click OK, right, so it will generate the normality test, because normality tests usually takes some time, so you have to wait for some times, but the results will be generated. you know yes, now the result is ready. You can see this test of normality, right? Here you have to pick up this result in SPSS. So usually, for your understanding aspect, let me take this result into Excel so that the better clarity and explanation can be provided. I hope normality is clear.
Yes, sir.
Right. So normality usually we apply for checking the normal distribution of the data. Right. So here we have to take the normality. So this is the normality test that we have it. Clear? And I zoom this result. Now you can see this result. We have to pick up this one. This is significant value. So this is significant value, which is called p value, right? This is called probability value, right? So when we talks about normality, we have to take this p value into consideration, right? So if this p value, you can see this p value, right? We know that the comparison of p value is with greater than or less than, right? I hope you know the rules. Can anybody tell me what is the rule? 0.05. Which hypothesis got accepted?
P less than 0.05, sir. Or
I hope you are agree what I am writing. Clear?
yes, greater is not accepted. Okay, okay, sir.
Right. Either or you can speak out, right? If this is accepted, then H1 rejected. Clear? And vice versa. So here, if you see this particular values, if you see these particular values, so this is what? 0 point. These values are 0.000, 0.000, right? So these values are greater than or less than 0.05. So instead of P, I'm writing 0.000. And now I have on the other side the significance level of 0.05. Now you tell me which one is highest one, 0.000 or 0.05.
0.05, sir, is higher.
Right. So we have learned that, the value which is highest one, we have to open the bracket in front of him. Right. So now what is the condition now? Is it greater than or less than? So what can we read it? Like 0.00 is called p value is, this is a sign of greater than or less than?
Less than.
Less than, right? So p value less than 0.05. So which hypothesis got accepted?
Alternate hypothesis.
Alternate. What alternate says that data normally distributed or not?
Normally distributed.
Not distributed. This says data are normally distributed, right? And this says data are not normally distributed. I hope I know because why you said this, because usually rest hypotheses are, null hypotheses are negative, which always start with no. But in the world, there are two hypotheses wherein the null hypotheses are positive. The one is the normality, and another one is variances. These are the two hypotheses where null hypothesis statements are positive. But in the world, the acceptance and rejection for null and alternative hypothesis in comparison to the p-value are common. I hope it is clear. Understood?
1 second, sir.
Clear?
Yes, sir.
Hello.
Yes, sir.
Sir, 1 second, sir. Couldn't
Where you
understand.
where you stuck up, sir?
Uh, Sorry, sir.
You are noting something, or you don't understand anything? Tell me so that I can.
Name, my actually I couldn't understand about that null hypothesis and both what you told.
Okay. Null hypothesis and all variance explained, right? So these are the two hypotheses in the universe which are having the null hypothesis statement to be positive, like data are normally distributed. Yeah, right. Equal
Okay,
variance
sir.
assumed, right? Wherein other inferential hypothesis, they says that there is no significant difference for null hypothesis. There is no significant impact. There is no significant difference of opinion. There is no significant association, right? So these are the different statements for null hypothesis when we talks about inferential statistics, right? But these are the two only data checking points where null hypothesis never say no, right? Wherein alternate hypothesis is having the statement of no, data are not normally distributed. For rest of the hypothesis, there is a significant difference. There is a significant difference of opinion. There is a significant impact. There is a significant association. This is alternate hypothesis when inferential statistics would apply. Clear?
Okay, sir.
Okay.
Thank you.
So this is how. So based on this, p values are less than 0.05. So whether your data are normally distributed or not, your data are not normally distributed, right? Because your p value is 0.000, which is less than 0.05. So acceptance and rejection of null and alternative is very clear. And according to that, only alternate is going to be accepted, right? And it is falling under the region of uh, you know rejection of null hypothesis. That means acceptance of alternate, and alternate says the data are not normally distributed. Clear normality test, everyone? Say yes or no. Or if you know, then what
Yes,
Yes,
was
sir.
sir.
Yes, sir. Yes, sir.
right? Okay. So based on normality, you have this particular option. Like, I will not discuss much on this, but yes, there are few tests which we have to apply, right? So you can see this. There are two groups. Two groups means what? What is this two group means? Right. This two group means, right? If I have two groups, just a minute, why it is not catching? These two groups means, let's say if I'm asking someone what is your gender, so gender could be segregated into male and female, right? So this is two groups. And if I want to see the significant difference of gender towards online banking perception, right? So first of all, I need to check the normality, right? So you can see this two groups below, data are normally distributed or not. And if the data is normally distributed, then it is called data is normal, right? And if the data is not normally distributed, then data is not called normally distributed, and that's why it is non-parametric test will be applied, right? So when you have a two groups in nominal and ordinal scale data, and in a contrary, on the other side, if the scale data are normally distributed, because I already told you that normality check can be applied on scale data, right? So if your scale data are normally distributed, and if you have two groups in nominal and ordinal data, you need to go for parametric test. And again, if the data are not normally distributed, then you can't apply normality parametric test. We need to go for non-parametric test. So if the scale data are normally distributed, and if the nominal and ordinal scale data is having two groups, you need to apply independent sample t-test, right? And if the scale data are normally distributed, not normally distributed, and if you have two groups in nominal and ordinal data, you need to apply Mann-Whitney U-test, right? So you have to apply Mann-Whitney U-test. Clear? So this is what the difference point is coming out. Clear? This is what we have to see to it.
Just repeat, sir. There was a break in your voice, sir.
When the scale data are normally distributed, and when nominal and ordinal scale data have two categories, right? Then we have to apply parametric test, and parametric test when the data are nominal, and when the nominal and ordinal data are normally distributed of scale data, and when nominal data is having only two categories of data like a gender, male and female. In that case, if the data turns to be normal, we need to apply independent t-test, right? Is in your screen it is showing. And if the data are not normally distributed in terms of scale data, then we need to go for Mann-Whitney U-test. Is it clear?
Thank you, sir. Yes, sir.
Right. And if instead of two groups of nominal and ordinal scale data, just like if I'm asking age, so I have more than two groups, like up to 20 years, 20 to 40, 41 to 60, and more than 60, right? So I have four groups, right, which is more than three, right? So in that case, I cannot apply independent sample t-test and Mann-Whitney U-test, because these tests are applicable only when your nominal and ordinal scale data is having only two groups. But if you have three or more than three groups, you need to go for the ANOVA test or Kruskal-Wallis test. But again, you have to see that when you have more than two categories in nominal and ordinal data, and if the scale data of your analysis, under which if the data turns to be normal, you need to apply ANOVA, and if the data does not turns to be normal, you need to apply Kruskal-Wallis. Clear? Which is also visible on the screen. Understood, everyone?
Yes, sir.
Right. And in the same time, if you come to this side, like continuous data, paired data, I hope you have heard about sometimes in medical test also, or even in social science also, like if you want to check the effect of some event on the same variable. For an example, if I want to check the effect of training program on the student's performance, right? So what I will do is I will check the student's performance before training program, and after giving training program, again I will conduct some evaluation per pattern, wherein I will try to check the impact of the particular training or particular guidance which has been provided to the students, and wherein I want to check the effectiveness of this training program, right, among the students, among the faculties. So I should have one variable, but the events are different. One is before and one is after. When COVID-19 was there, this research has picked up so many catchy point at the time of COVID-19, especially for finance people, where stock market performance was evaluated, where the company performance was evaluated with the consideration of COVID effect, right? While what was the effect of COVID-19 before, so what was the effect of company's performance on particular policy before COVID-19 and after COVID-19, right? So people were taking 2 years data before and 2 years data after, and they were checking the impact of COVID-19, right? So that's where the parameter is same, like I want to check the net profit, right? So I will check net profit before COVID, and I will check net profit after COVID, right? So although the parameter was same, but the comparison was different. So that is where before and after conditions, wherein we have to make the continuous evaluation of the data in terms of parametric and non-parametric, wherein both the data are scale data, right? Because if I need to check the company's performance, the performance can always be in a scale data, right? It always in a continuous variable, it always in a number data, right? So I will check the scenario before COVID-19 and I will check the scenario after COVID-19, right? So the wherein I will decide what exactly the thing is going to be, right? And if in that case, if the data turns to be normal, you need to apply pad t-test, right? Pad sample t-test. But if the data does not turns to be normal, we can't apply pad sample t-test, but we need to go for Wilcoxon sign rank test, right? We need to go for Wilcoxon sign rank test, right? So this is how, as I hope you have find out on the screen.
Yes, sir.
Right. So if you want to check the impact of certain event on particular variable, so we need to come out with Wilcoxon sign rank test. So now whatever test I have shown you, let me drag you to the SPSS, right? And if you want to apply any data which is parametric, right, you need to come to compare means, and over here you can see this. I told you that if you have nominal data and where the categories are two, for nominal and ordinal, and the scale data are normally distributed, you have to come for independent sample t-test, wherein I have only one nominal data where two categories are there, that is gender, wherein one is male and another one is female. So I have to put one in group 1 because it was coded one as male and two is female, or vice versa. And I want to check there's significant difference of opinion for this particular factors, right? So I will click on this. So these are the factors, right? And I'll drag onto this side and I'll just click OK, nothing much. So now you can see this. This is, test results, as you can see on the screen. And you can see this 11s test for variances, right? So I told you earlier कि दुनिया में दो हाइपोथेसिस ऐसे होते हैं जिसमें नल हाइपोथेसिस पॉजिटिव होता है, जिसमें एक होता है नॉर्मलिटी और दूसरा है वेरिएंसेस, right? So again I have to make the hypothesis statement for this. So I'll say this. You can see the first one. You can see this. Let me take this to the Excel, and you can see this result over here, right? So here you can see this equal variance assumed and equal variance not assumed. Can you see this? Yes or no? Understood? Equal variance assumed and equal variance not assumed. Yes or no? Right. So equal variance assumed and equal variance not assumed, right? So this is what the
Okay.
hypothesis is. So this is null hypothesis, right? And this is alternate hypothesis. You tell me, whether by looking at these equal variance assumed values, right? This is called Leavener statistics for equal variance assumed. So we have to see this table, and over here you have to see this. So you have to see the significance value. All the significance value are greater than or less than 0.05.
Greater than.
Greater than. So which hypothesis got accepted?
Null hypothesis.
What null hypothesis says that equal variance assumed or equal variance not assumed?
Equal variance is assumed.
Right. So for every factor, there are two p-values which is given, right? Wherein this value is for equal variance assumed and this value is for equal variance not assumed. Should we look forward for equal variance assumed or we will forget? We should avoid it because our variance result says that equal variance assumed, right? So everywhere I should hide this result. It is no use. So whatever reporting I will do it on equal variance assumed p-value. And then I have to check this inference statistics p-value, which is called over here, right? Which is here, right? And now I have to see this value. You can see this p-value is 0.176. So now the inferential hypothesis says that there is no significant difference of opinion between male and female for the online banking factors, right? So the first factor of online banking is motivation. So for motivation, I have received p-value 0.176, which is greater than or less than 0.05. Obviously greater than, na? It is 0.176. It is
Yes,
obviously
sir.
greater than 0.05. So which hypothesis got accepted?
Null
Null.
hypothesis.
Null hypothesis. So inferential statistics, null hypothesis says what? There is a difference of opinion or there is no difference of opinion.
No difference.
Perfect. No difference, right? So inferential statistics hypothesis always consider no words in null hypothesis, right? Understood? This is how you have to interpret. Understood,
Yes,
everyone?
sir.
Same thing you can do it for ANOVA also. Acha, let me take these non-parametric version of this test only. So if you want to apply non-parametric version of this test, then you have to come over here, non-parametric test, legacy dialog box, and you can see this two independent sample t-test, right? And again, the same thing like a gender, I have to drag it here and define group. 1 is for 1 and 2 is for 2. And factor 1, shift, click OK. And now see the results. So all the p-values you can see over here. Is it greater than or less than 0.05? All the p-values you can check. All the p-values are greater than or less than. अरे p-values, where is p-value? वो p-value लिखा नहीं मिलेगा.
First column, sir.
Not first column. Asymptotic significant. You can see this. Even you can refer it from the point value, right? 0 point something
Yes,
value.
sir. Yes, sir.
Oh, yes, sir. Yes.
All are greater, sir.
All are
Greater.
greater than
0.0.
0.05. Yes or no?
Yes, sir. Yes,
Yes,
So
sir.
again, for this,
Yes,
null
sir.
accepted or rejected.
Null hypothesis will be accepted.
So there is a difference or no difference.
No difference.
No
So even you
difference.
apply parametric or non-parametric, there is no much difference in the results. But although practically when data not normally distributed, so you cannot apply the mean value as a comparison, but you have to apply mean rank value as a comparison, right? So that is what the basic difference between parametric and non-parametric test. Is it clear, everyone?
Yes, sir.
Yes, sir.
Right. Again, for same thing, let's say if you have more than two variables, so for parametric, you need to go for again compare means, and if you have more than two variables, you need to go for one-way ANOVA. Clear? So this is one-way ANOVA. So wherein you can take any values, like if I'm taking age, so how many groups are there? 6 group. So I need to drag age into factors, right? And again, I have to take these online banking factors. Clear? And if I'll drag on this side, right? And if I click OK, I have the results. Again, you take these results. You can see these ANOVA results. This is the p-value, which you can see this. For all the variables, you can see these results. What is your opinion about this result?
Sir, it is less than 0.05.
0.05, right? So there is a
Null
difference.
hypothesis, null
Null,
hypothesis will be rejected.
perfect. And there is a difference of opinion between different age group people for the
Yes, sir.
user-friendly factor of online banking. Clear?
Yes, sir.
Yes, sir.
Right. So this is how the different test you can do it. Again, for ANOVA non-parametric versions, if you go to analyze non-parametric test, and if you go to legacy dialog box, and if you go to k independent test, and again you drag age over here, wherein you have to define range. So minimum 1 and maximum 6 is the age group range, so that we have to apply. And then shift and select all the factors over here and just click OK. You will have your results. You can see this test statistics. Again, you can see this. For non-parametric also, you see the results. You tell me what is the interpretation. Yes, you see the results. What could be the interpretation? What about this? Greater than or less than?
Greater than.
Less than, madam. There are
Less than.
zero. There
Less.
are point
Oh,
double two zero hai.
okay.
Right. The significance says that only 0.05. It is
Yes.
0.008.
Yes, sir.
Yes,
Right.
yes.
Uh, so please be careful, when you are doing research, when numbers always, makes you confused. Clear? So in
Okay,
this
sir.
case,
Thank
which
you.
hypothesis got accepted?
Alternate hypothesis.
What it says? Difference of opinion or no difference of opinion?
Yes, sir.
Difference
Significant.
of opinion.
Perfect.
Yes, sir.
So I hope you have some clarity on this. So that's it from my side. I am making this session open for question answer. If you have any questions, you can ask. Yes, please. Any query about related to your research work, any research paper, so you can ask. I hope it is clear to everyone. Most importantly, null hypothesis, inferential statistics, the acceptance rejection of null and alternative, very, very important parameters. Clear? Yes, questions, please. No questions? It's a big question. Either you understood everything or you don't understand anything. What's the situation, please?
Understood, sir. It has to be applied. That's it.
Right. Right, so no questions at all? Okay, so thank you so much, all of you, for connecting. I hope this is going to be useful to you and you can carry your research to the next level. Thank you, all of you. Thank you, Research Foundation of India, Ajay sir, Saurabh sir, and all the coordinators for the events. Thank you, all of you. Good night.
Thank you, sir. Thank you, sir.
Thank you. Yeah.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Thank